Hey guys, we're going to move on with logarithms. One thing I want to kind of sum up is that your intro to logarithms ended up quizzing very well. Yesterday we looked at properties with logarithms, right? Kind of funky things you can do algebraically with them. And today we are going to solve equations and inequalities that involve logarithms and their inverse counterpart, which are exponential. So with that said, let me just start off with something very basic, okay? If you have an equation as such, or let's say you don't, okay, you can change it into this form where you introduce the base b to both sides. You still have preserved the equation, okay? So if you have this form, you can actually go left, or if you have this form, you can go right and produce that form, okay? So we've basically produced exponential equations here, okay? An equation, or exponential expressions. Now let's go ahead and follow the same kind of train of thought, right? If you have x equals y, we can go ahead and take the log of both sides, log of x, and now we've introduced logarithmic expressions and we've maintained equality. So this right here is going to be huge in our approach to solving the next couple of problems. Okay. All right. So let's start off with this one. It says solve the following problem. Okay. Now, as you're looking at this problem, sure it's new, but something that should come to mind is the fact that this 8 and this 32 must have a common base, right? Some common base, different exponents. So let's go ahead and take that approach. So 8, most of you guys are comfortable to know it's 2 cubed, x plus 8, equals, same thing with 32, it's 2 to the what? 4, 8, 16, 32, okay, to the x. Well, algebraically what I can do, I know that an exponent raised to an exponent creates multiplication, so really I'm going to write this way too. I'm going to put the 3 out here now with the x plus 8, and this guy out here is really just the 2, okay? So the focus is that I've now got matching bases and I can perform whatever math is out here. Right? Alright, so with that said, I can carry out the math here, but one thing I'm going to go ahead and do here is I'm not going to apply one of these tactics from our intro here, okay? And I'm going to take the log of both sides. So check this out, okay? I've got that equation, and I'm going to take the log base 2 of this side and the log base 2 of this side. Okay, I've put it in red so that you can see that it occurred afterward. Okay. Now, what am I getting at? We are getting to, or let me use our little star method here. Okay, I'll put it in here, quotations. I'm using the fact that what? Log base b of x equals x. Okay? So let's be very clear what I'm using here. So I've got this in quotations here, just kind of like a comment, not part of the math, but this is what's going to explain my logic here. So because I do have this common base 2, I've introduced a log base 2 because I do know that this will cancel, as will this. So all that's left is the exponent, which is this and this. Okay, so what's going to be left over is the 3x plus 8, and this is tied into our properties of logarithms, equals 5x. And now I can continue with this as a very basic algebraic problem. So I've got 3x plus 24 equals 5x. I'm going to subtract the 3x to both sides. I'm going to divide by 2, and I have x equals 12. Alright. Again, capture as good a notes as possible. See what you can do with that alone, and please come with questions, comments, and concerns tomorrow. We'd love to have that discussion together. Okay. Alright. Next up, what are we going to do here? We've got to solve this problem, okay, this equation, logarithmic equation. However, or what I'll take into account is the fact that there's this minus. We looked at something yesterday like this regarding logarithmic properties. So let me go ahead and reintroduce this. Now I'm using quotations because we no longer are necessarily using formulas directly, although there's an implied knowledge there, okay? So this is not part of the solution process necessarily, but it is knowledge that we're basing our solution process off of, okay? So what did that look like here? We had log base b of m minus log base b of n, which ended up equaling what? Log base b of m over n. Okay. I do like to put this expression here, this value, in parentheses so it can much more easily be distinguished from that base b. Anyway, so that's just kind of what I'm feeding off of. But let's go ahead and continue with this process. So if I was to apply this knowledge in here, right, just on the left side of this equation, this 21 I can kind of disregard, then I'd have log, right, I need a base b, which is obvious, it's 5, and I would have m, which is x over 10 over what? X to the 6. Don't forget, equals 21. Alright, next in this process is, like we've done in the past, just kind of further simplify, when possible, the expression in the parentheses. So this is x to the 4th equals 21. Alright, what can we do here? Alright, what we're going to do is we're going to rewrite the problem now, since there's not much we can do. Okay, I'll just get rid of the parentheses. Why? Because this should trigger your memory of the power property of logarithms. That tells you what. Okay, and I'm going to put this again here in the middle in quotations. Not necessary as part of the solution process, but it's our conversation as to what is he doing, right? This is where we had the log base b. I think here we had an a to the p. Okay. And what does that do? You're allowed to put the p up front, log base b of a. Okay? So this is the bit of knowledge that I'm going to apply here. So then I'm going to have 4 up front times log base 5 of x equals 21. Alright, now what are some options here? Well, I think the first time we always make things more difficult, but if you really look at what's happening, it's 4 times this value, so I can actually do the opposite and divide by that 4. And now I have log base 5 of x equals 21 over 4. Okay, interestingly enough. And again, this is the log, so that's exactly what we're working with now. So the question is, what are some options here? All right. What I'm going to introduce here that's new from yesterday's properties, okay, is this little bit of information here. Check this out. Okay. I'm going to put a star here since it is relatively new. We did talk about log base b of b to the x equals x. Okay. This is not new. However, what we can do is we can actually take some base b, or introduce some base b to a log b of x, and end up with the same result x. Why? Once again, because exponential and logarithmic functions are inverse operations. They cancel themselves out, and would reduce to x. So the way I'm going to apply that here is I'm going to introduce a base 5 to both sides. Okay, so notice what just happened. It's 5 to this exponent here, and 5 to this exponent here. Okay, so just to avoid this causing any confusion, I'll rewrite it here. So I've now got 5 log base 5 of x equals 5 to the 21st to the 4th power. Okay. Why did I do that? Because this property guarantees me that so long as the bases match, They'll cancel, and I'm left with x equals 5 to the 21st over 4th power. Alright, let's go ahead and move on. Looks like this may be the last example here. Alright, so this next one says use a table and graph to solve the following problem. Okay? Although there's multiple approaches, we're going to be literal and follow these steps. So the first thing that I'm going to suggest is enter this in the calculator as your first function y1 and this as your second function y2. Okay? So 3 to the 2x. So we got raised to the 2x. Okay, we'll hit enter. Tab. And this next one, where is it? It's 65, 61. 61. Enter. Alright, so it's because the y value for the second function is so large, it's really way up there on the y-axis. But it did request a table, so let's go ahead and hit Control T. Can kind of explore what we're looking at here. Right. Now, remember, the problem asked for us essentially to solve this problem. So we're looking at essentially where these two graphs intersect. And if you look at this table, you look at x equals 4, we have the same y value. So that would be, this would indicate the solution. Okay. So let's go ahead and capture an image here real quick. This is essentially the proof that's required for this problem, since we do have the graph and the table. Okay. The only thing that would need to be addressed is this y2 isn't displayed on here. So what you can indicate is maybe something like ... about 65, 61 is where this line is. And it intersects just about there. Okay. Alright, the main thing is being able to use the table to find the solution. I could take time and kind of scroll up on the graph on the calculator. It's not necessary here, but you can do so for your peace of mind, see where they intersect. Alright, let's move on to the last problem here. Solve b raised to x minus 2 is less than c. Alright, what are some options with this problem? Let's see. What you can do is maybe pause the video here and kind of guesstimate as to what your approach would be. Alright, what I'm going to do here is I'm actually going to take the log of both sides. Again, my understanding is that if I have some quantity x equals to y, what I can do is I can take the log of both sides and have the log of x equals the log of y. Whoops. Alright, again, not part of the solution process, but this is the knowledge that I'm going to apply here. So then in that case, I have log of b x minus 2 is less than the log of c. Okay. What's that going to allow me to do? And again, it's not necessarily intuitive, but you know, you're taking notes, you're thinking about it. That's all you're being asked to do here. There are questions, comments, and the working out of problems more in class will happen then. Okay. All right. The reason that I've taken this approach is because now I can apply the power property of logarithms. And let's go ahead and in quotations remind us what that is, or what that tells us. It says if you've got log base b of some expression a, we keep on using p, so we'll stick with p. What you can do is bring that p up here in the front and retain everything else, right? Okay, so that's the knowledge that I'm going to be applying here. So with that said, I've got now x minus 2. Okay, before I get these guys get lost, I'm going to lump them together in a parentheses. I've got log base b, excuse me, okay, equal to log of c. Now, today in class, it was mentioned that if there is no base explicitly labeled, you can assume it's a 10, base 10. Now here that doesn't really matter, but the knowledge of that fact is important, okay? So keep that in mind. I'll write it in this one time here. If I don't write it later, it's just implied, okay? Why? Because log base 10 is very common, and like in other situations, it's so common that we just refuse to write it so much and it just kind of disappears. It's implied there, okay? All right. So if I have that, the next logical thing is something times this equals that, so I can actually divide by the log of b. Okay. Let me go ahead and maybe do that in red here, see if that helps a bit. Okay. Just to kind of differentiate between steps. So I'll go like this, log base 10 of b divided by log base 10 of b. Okay, I'm sticking with the base 10. It's about to disappear here. See if I can keep my promise. So this and this are the same, so they'll cancel. So I'm left with x minus 2 equals what? Log of c. Notice the 10 disappeared, but it's still implied over the log of, what is it, b. Okay. And then lastly, what I'm going to do is add 2 to both sides. So I'm left with x equals the log of c over the log of b plus 2. Guys, thank you like always for your time. I can't wait to respond to questions, comments, and concerns tomorrow in class. Have a great rest of your evening.